Over the past 50 years, humans tirelessly explore their cosmic neighbors, searching for the basic elements of life. We're sending a rover to Mars, drilling in the rocks, also flew high above Venus, searching for traces of water in that thick atmosphere, even brought back water samples from asteroids. However, even with these achievements, we still haven't found the key elements of life. Now, we're pinning our hopes on the Falcon Heavy. This time, we're going to explore a whole new environment: Jupiter's icy moon Europa. At first glance, Europa appears to be an unlikely target. Jupiter is far beyond the solar system's base belt. Europa is also only slightly smaller than the moon. Satellites are usually made of rock. It has almost no atmosphere. Harder to have a magnetic field strong enough to withstand solar radiation. Such an environment, disease is also very bad for satellites. Although Europa's solar panels can, in the sun, draw energy, but its light intensity is only 4% of that near Earth. Jupiter's powerful magnetic field focuses solar radiation and guide to its surroundings. And Europa is right in this radiation belt. This intense radiation, enough in less than a day, destroy the electronics of ordinary detectors. Then since it's so bad, why National Aerospace? The Bureau also holds $50 billion. Dispatch probe to explore the vital elements of Europa. Let's find out. This Europa Clipper mission. What will happen? Transforming our understanding of life beyond Earth. We have long speculated Europa may have the potential to harbor life. This speculation comes from studying the ice beneath it. Doubt about the existence of a huge ocean. The earliest direct evidence from the Voyager probe. They flew 250,000 kilometers from Earth. Time captured bizarre images of Europa's surface. Its surface is smooth and flat. Crater scarcity. But there are long limits. These limits appear to be formed by the movement of ice. This discovery ignited the imagination of scientists. Then the Galileo probe also went to Jupiter, acquired more stunning photos and data. However, during the mission, the Galileo had an accident. As he approaches another moon of Jupiter, the probe lost valuable data. It turns out that high-energy electrons penetrated the detector, changed one bit of data in internal memory, forced it into safe mode. Galileo spent too long in Jupiter's radiation belts. The radiation dose is already designed to withstand only 3 times the limit this radiation makes us aware of. Life is on the surface of Europa. Almost impossible to exist, and that's why Europa's ice is so important. He can provide a radiation screen for the ocean under the ice. But strangely enough, radiation itself, maybe it's Europa that has life. The key to potential, when the ion body and charged ions bombarding the surface of Europa, strong oxidizing agent is formed, such as hydrogen peroxide. If these oxidants can, penetrating into the ocean beneath the ice, reacts with other molecules, it is possible to form a supply, the complex mixture of molecules that life uses. In addition, the attractive force interaction between Europa and Jupiter, another source of energy for life. Due to its eccentric orbit, it's constantly expanding and changing in its orbit. The resulting frictional heat, perhaps the ocean, maintain a temperature suitable for life. So how do we determine what's beneath Europa? Is there really an ocean? This is thanks to the Galileo. Magnetic strength agent of the detector. Magnetic strength agent, a mechanical coil wrapped around a metal ring. One side coil wound clockwise. The other side is counterclockwise. A measuring coil is also installed outside it, used to detect magnetic fields passing through metal rings. In the absence of an external magnetic field, these opposite coils will cancel each other out, generate an impending magnetic field. But once placed in a magnetic field, the ring core will slightly deviate in the direction of the magnetic field. The external coil can sense this deviation and convert it into a current signal. To accurately measure the magnetic field, the magnetic wall of Galileo, so around Europa, a bizarre magnetic field deviation has been detected. This deviation, only underground rich in dissolved ions. The ocean. Detector found. The salt in this ocean is similar to that of Jupiter. Powerful magnetic fields interact, forming Europa's own induced magnetic field. This magnetic field is incredibly powerful, because Jupiter's magnetic field is 20,000 times that of Earth. However, what is even more mysterious is that Galileo was launched twice in 1997 and 2000. Close flyby. Europa time. Magnetic field detector recorded unpredictable, violent fluctuations. In 2014, scientists finally solved the mystery. Captured by the Hubble telescope. On the surface of Europa. Water vapor eruptions up to 200 kilometers. After a series of modeling, researchers realized that Galileo most likely flew over these iron-rich salts. Water and flow because of this. The Europa Clipper mission is full of anticipation. This icy moon is full of mysteries. There are still too many unknowns waiting to be answered. We don't know the exact thickness of the ice. It is also impossible to determine whether it is sufficient to block powerful radiation. These questions, it's just the Europa Clipper mission, one of the many mysteries that need to be solved. And this probe is designed to be much more than that. According to the original plan, Europa Clipper will complete the space launch system. The rocket flew directly to Jupiter. However, due to the tight launch window and high cost, the mission was redirected to the Falcon Heavy. Although so, saved about 11 billion RMB for launch cost, but Falcon, the thrust of the Heavy police, is not enough to support direct flights within 3 years, and what we have instead is this. The Clippers will take a longer route, passing Mars and Earth. Use their attractive force. The first challenge facing the Clipper is to enter a special orbit around Jupiter. To avoid the strongest radiation belts, it can't orbit Europa directly. Otherwise, the lifespan of the probe will be reduced from the expected 3 years, sharply reduced to about a month. Therefore, the Clipper will take a highly elliptical orbit. It passes through Jupiter's radiation zone every 14 days and flies past Europa at 4 kilometers per second. In a short, close leap, the probe will do its best to collect a large amount of data, then withdraw to a safe area. It takes 10 days to transmit data and adjust the orbit. The Clipper's core electronics is placed in a thickness of 1 centimeter of aluminum alloy flat bottom box. This safe is the core of the probe. Protection system. Engineers calculated in detail the radiation agent that the detector may be exposed to. The quantity is guaranteed to make a close leap, extend its lifespan to the greatest extent possible. 3 magnetic wall techniques on the detector will further reveal the magnetic field structure of Europa. Help us improve a comprehensive understanding of the characteristics of the subsurface ocean. To avoid the metal structure of the detector, magnetic field interference toxin, scientists have designed a 8.5 meters long carbon fiber extension arm. Move the sensor as far away from the main structure as possible. The flexibility of carbon fiber allows for expansion. It unfolds without any mechanical devices. Fast pass, I also hope to reserve through crossing. Direct collection of materials from the ocean. Sampling of detectors. The device will fly at close range. Open the cover. Let the dust particles in. Measure its speed and composition. These particles, after colliding with the metal surface of the detector, will break down into basic elements and ions. The power plant directs these ions to counter at the end of the detector. Past differences in flight time to identify different ions. Even if you can't get through the rain, the detector can also pass a spectrum. The instrument analyzes the composition of the surface material. Its infrared and ultraviolet spectrometers will cover different bands. Reveal Europa for us. The structure and composition of ice sheets. In addition, the detector will also pass. Measure its acceleration under attractive force. Mapping the attractive force of Europa. Scientists hope that by flying multiple times, the change of Kilu Europa not going down towards the west, it only takes about a 10th flyby to keep the error within the ideal range. Europa, the Clipper's camera system has also attracted attention. To 8 million. The prime camera will capture wide-angle and narrow-angle images. After multiple flybys, covers 890% of the surface area of Europa. Resolution up to 100 meters per pixel. This image quality is not only far superior to Galileo, it will also help us understand surface dynamics of Europa. The detector's radar system will use different frequencies. Rate of electromagnetic waves through the ice. Measure its thickness and fluctuation. Low-frequency waves can penetrate thick ice, but Jupiter's infinite interference limits its distance. Use on the side away from Jupiter, high-frequency waves are not disturbed, but susceptible to the roughness of the ice. With these detection methods, we will be a clear understanding of the existence of Europa's ocean. Although the probe relies on solar power, but with the previous use of the Ministry, 238 nuclear batteries have different detectors. This mission decides It uses 30-meter-long solar panels. The half-drop of the supplement, to 138, is 88 years. It is an ideal energy source for space exploration. However, NASA's inventory is running low. The only task currently confirmed to use non to 138. It's a Dragonfly probe to explore Titan. Europa Block ship will uncover Jupiter for us, the mystery of the beetle nut satellite. This mission is not just a scientific adventure. It is also a time for humans to understand the universe. A bold attempt at life exploration.